Hey everyone, welcome back to this course. In this video, I just want to go over the assignment for this week. So this week we're going to be working with the electronic test equipment that we have in the lab. I've just provided some definitions here for you guys to familiarize yourself with. What's most important probably is this definition of parallel and series connections. And we're going to be using the buzzer. That could be important too. Actually, yeah, just all of these definitions, pretty much just try to understand them before getting into lab today. So we've got these corollaries which will come into play on the first part of the assignment, right? So voltage in parallel is equal, current in series is equal. So when we're taking measurements of voltage, we should apply our multimeter, or our voltmeter in this case, in parallel with the element that we want to look at. And then when we're measuring current, we want to apply the ammeter in series with that element. So right here are some circuit symbols. You should just review these. I assume some of you have taken the quiz already and have read through this, so I'm just going to skip through. So here's the equipment that we will be working with in lab. This first unit is a power supply. So the first thing you want to do, right, is turn it on. Don't worry about any of these. We won't be using those. And we're only going to be applying 5 volts, so you can select this 6 volt output, and that will utilize these terminals here. Right, and then make sure that you turn the output off, and then you can change the limit, right? So we can adjust it to 5 volts using this knob, and you can set the current or the voltage. Make sure you're setting the voltage to 5 volts, not the current, because 5 amps is a lot of current and can be dangerous. And then once you have connected your circuit together and are ready to test it, is when you should toggle this on-off output button here. Moving right along, this is a decade resistor box that we have in lab. So right here is where the terminals are, right? So it's going to be resistor like that. And you'll notice a little arrow here that just means that it's variable. And you can adjust these knobs to get whatever value that you want. You'll notice that the only knob that is really set is this 1K. So right now this is a 1 kilo ohm setting for this decade resistance box. Right, so when you're connecting them in series or parallel, you'll just use these two terminals here, right? And so suppose we have another decade resistor box. If we wanted to connect them in series, right? And if you had another one of these, you would just connect this to the terminal of the other one. And then here is our multimeter. I think some of the benches might have different multimeters, but this one is pretty common. So just taking a look at this. We're not going to worry about this. We're not going to worry about this 10 amp. This 4 wire setting. We're not going to worry about that today. But here is where we can change the settings for a voltmeter or an ammeter. So DCI is DC current, and DCV is DC voltage. And I think today we're just going to be measuring DC, so direct current, which just means it's a constant voltage coming out of our power supply. Right, so to measure voltage, we would use this terminal, right, so this is a voltmeter, and suppose we're measuring the voltage across some resistor, right, so we would connect our voltmeter in parallel with that resistor in order to measure the voltage, and then to measure current, right, we would connect this terminal and also the same kind of common ground here in series with the resistor. So hopefully that makes sense. If you have questions during lab, just let me know. So current in series, voltage in parallel. And then you can switch between voltage and current with this shift button here. And you just toggle current and voltage. So then moving right along, this is the function generator that are at some of the benches. With the function generator, right, you just turn it on here. You select the waveform here, and then there's some settings for frequency and amplitude of our wave. And you can, I think, there's some buttons that allow you to adjust the frequency and amplitude. But so with the function generator, our main settings are frequency, amplitude, and waveform. And you should be able to adjust those. Right, so here's the sine wave. Triangle wave, square, and rectangle. And this is our oscilloscope. So it's got BNC terminals. This is our two channels, right? So first of all, just walk through this. So the power button is over here on the left. If it'll zoom. Power button's here. There are knobs that you can adjust horizontal and vertical scales. So horizontal is the time scale, right? So we're looking at voltage over time, and the vertical scale is for voltage, right? So on the oscilloscope, you'll have these divisions, right? So then on this axis is time, and on this axis is voltage. So volts per division. I think this is seconds per division. And each of these knobs correspond to these two channels. So we've got two channels, so two different waveforms that you can look at the same time. We're not going to worry about any of these today or these. We're pretty much just going to be trying to get a single, right? So once you have an idea of once you think you have the right time scale, you can just grab a single capture of one period of your waveform that the different waveforms that you'll be looking at. So moving along to the assignment, right? So here's that 3 resistors in series, 3 resistors in parallel, and then just grabbing scope capture of one period. And then for this part with the potentiometer, right? So a potentiometer is kind of like a variable resistor, but here you have a little wiper that you can adjust some kind of knob and change the resistance. And then you'll just be probing the center tap, which is kind of like where the knob is. And then for this pulse width modulated signal, just read some of the background on that on the Arduino reference. Should be able to find it. So with that, I'll see you guys in lab.